Hey everyone, today we're going to use Starwalk to do something that we normally can't do. We're going to do some stargazing while the sun is still out. As you can see here, the sun is very close to setting down in the west, but it's just thanks to Starwalk we're able to check out all of these constellations and stars that are out, even though it's daytime. Very handy. That's what this kind of technology was made for. And let's start with the sun because that's going to be the focus of the astronomical lesson for today. As we look at the sun here, you can look directly at it on this app, which is fortunate. As you look at the sun, you see this yellow dotted line that it sits on. That, I'm going in reverse here, from west to east. This is the path that the sun follows, this yellow dotted line. And there you see where the sun rose in the east earlier today. Let's follow it back. So the sun followed this yellow dotted line, this path. This path has a couple of different names. It can be called the day arc, or it can be called the ecliptic. Think like solar eclipse, but it's an ecliptic. That is the path that the sun travels. And once it sets, it doesn't just stop and reset over in the east. We can go down here into below the horizon, and you can see the ecliptic continues down below until it rises once again in the east and starts a new day here. Now you'll notice that the ecliptic is rather low in the sky right now. We are past the autumnal equinox. It is now October. So the days are shorter than the nights. And you can see the sun is pretty low in the south as it follows the ecliptic. And that's going to be the case in the fall and in the winter. Once we hit the vernal equinox, the spring equinox, the ecliptic will move up, not all at once, gradually, of course. It will move up, and soon it'll be crossing the sky in a more northerly direction. But since we're in the northern hemisphere and well above the tropic, the ecliptic will never cross the very middle of the top of the sky, which is called the zenith. If we look at the zenith right now, you can see we have the constellations Lyra and Hercules up there. A couple better known constellations. Now, for the ecliptic, what I'd like you to do is, as I go around the ecliptic once more here, I want you to take a look and see what significant celestial bodies appear on or near the ecliptic. So, let's follow the sun down below the horizon, get a good view of the ecliptic. There's one significant body. We have the moon that is also very near the ecliptic. You may recognize some of the star names as we go by as well, some of the constellations. There's Uranus, also on the ecliptic. As we continue up, right above the horizon there is Neptune. Mars is not far off the ecliptic, a little bit south of it. We continue. There's Jupiter, very bright planet in the sky. And you can see just below the ecliptic there we have Venus and even Mercury. So you can see that the path that the sun takes, the ecliptic, is also where you would find all of the planets as well as the moon. That is because our solar system is a disk. Even though we are a ball hurtling through space, we are arranged on this disk of the solar system. So all of the other bodies in that solar system, the sun and the other planets, will appear on that ecliptic, on the same plane. What I'd like you to do is rewind this, or, well, heck, you can take a look right now as I go by the ecliptic one more time. You may recognize some constellation names that are right on the ecliptic. This time we're looking at constellations, not planets. And what do you notice about the names of those constellations on the ecliptic? I want you to think about that. List the different constellations that are right on the ecliptic. What might be their significance? It might tell you something about some of the history of astronomy and how the stars influenced culture. So thanks for checking this out. Hopefully you can impress your friends and family with the newfound knowledge that you found here, and